Okay, so in this video, I'm going to be talking about zener diodes. So, before this, as a precursor, if that's how you use that word, you should watch the video I made about diodes so that you can have a better understanding of what's happening here. Yeah, I would say, yeah, you need to watch the video, or at least have prior knowledge of a normal diode, how it works, before this. Okay, so, but as a recap, okay, we have two diodes in front of us here. This is the normal regular diode, and this is the main attraction for today, the zener diode. So let's do a recap on a regular diode first. All right. So the main function or the main purpose of a diode is to allow current to flow through one way and prevent current from flowing through the other way. And this direction is denoted by the symbol here. So this like triangle thing, this shows which direction it is alright to go through, and then this bar is like stopping, right? So it is wrong to go through here. Is wrong. So that's how a normal diode usually works. Here's the thing with this diode, right? No matter how large the current, as long as it's not like above the current rating, the electrons can just flow. Oh well, no, the current can just flow through here to the right. It's alright, and of course the current here will be blocked. But in the scenario where the current that is actually going against the diode is large, is powerful, yeah, it will actually destroy the diode. So what happens is like it's like if you have a dam and then like a missile hits the dam, the water just immediately starts rushing. So what happens when a large current goes against the diode is that the diode completely breaks down and then it just stops working. So this entirely breaks down and then it just acts like a wire, and then all the currents can go to the left as much as they want, and then it's broken forever. So that is the bad thing about the diode lah, is that at a certain point, it will break down, and that certain point is known as the breakdown voltage, or like VBR for these regular diodes. So VBR. Usually for these diodes, the normal diodes, it's like 50 volts. So if it goes against here, right, the voltage to the left is 50 volts, then it'll just like break. Yeah. So that's the recap on normal diodes. So let me talk about the zener diode. So the zener diode, right, it works exactly the same as the regular diode. It allows current to flow through one way, and it opposes current to flow through the other way, to the left in this case. Oh yeah, and to draw a zener diode, you just need like this leg here. Then that separates the zener diode from the regular diode. So yeah, it allows the current to go to the right and prevents it going to the left. Here's the thing with the zener diode, right? Remember how I said in the previous, the normal diode, that if the current is large enough to the left, the diode will break down and it will just cease to function as how it's supposed to function. Here's the thing with the zener diode. It has the exact same issue. However, it is much more fragile. In the previous diode, I said that the breakdown voltage is around 50 volts, so it's going to take quite a bit of effort and power to break down that previous diode. But the thing with this one is, it is built to be broken down. In its use, it is meant to have current flow to the left, and as such, its breakdown voltage is usually around like 3.3 volts. In some cases, 5 volts, 9 volts. It's a very small voltage, basically. So it has this function where the breakdown is very small, and then the diode is just built to be able to withstand these kinds of opposing currents. So why is it just a worse version of the normal diode? There are functions to this, but let me go through the specifics here. So these two graphs are basically just enunciating what I said for the past few minutes. This is the normal diode. It allows current to flow. It allows current to flow when the voltage is positive here. Um, and this is the knee voltage and all. Yeah, you should know this. And then when the voltage is negative, it tries to make the current be zero. And at a certain point, which is the breakdown voltage, it just busts and it just breaks. Okay? Point of no return type shit. For the zener diode, the graph looks exactly the same. It's just that the breakdown voltage is much smaller. So, okay, yeah, that's the graphs lah. Do you need to know these graphs? Yeah. Yes. Yes. Yep. Okay. So you may be asking, or you may be wondering, what the hell is the point of the zener diode? Right? It's so friggin' useless. Um, and the main point for zener diodes use, right, is voltage regulation. Okay. So let me show you an example here. So here we have VCC connected to here, and it outputs the ground and all this crap. And we can see that the diode is actually in reverse bias now. So in a normal case, or in an ideal case, the current never flows through this circuit. But due to the nature of the zener diode, and since its breakdown voltage is so small in normal zener diode live cases, this is a closed circuit lah. So okay, what's the point? What's the point of the zener diode? The point is here. It is illustrated in this graph. So red is VCC, and VCC in this case is a variable power source. As you can see here, the voltage is kind of like goofing around. V is actually the voltage across the zener diode, and the breakdown voltage for this zener diode is 3.3 volts. I forgot to mention, usually the breakdown voltage of the zener diode is notated as VZ, the subscript Z here. Okay, so what's the point? You can see how the voltage is being all willy-nilly. We can see this 3.3 volts, and then we see the voltage across the zener diode. So note how, right? It is acting alright, normal. The voltage across is chill, and then suddenly, at 3.3 volts, it stops. It stops increasing. It does not follow VCC anymore, and it gets clamped to the 3.3 volts breakdown voltage of the zener diode. And that is pretty much the use of the zener diode. So what it does is when the voltage across it, right, is higher than its breakdown voltage, the voltage across it then gets clamped at its breakdown voltage. So it does not allow the voltage across it to be higher than its breakdown voltage. Someone get a voltage counter right there. I said like voltage 15 trillion times. Alright. And this is useful in full bridge rectifiers, which I have a video on. You can go and watch that. It is useful in voltage regulation for circuits because perhaps you have fragile components in your circuit, right? They can't be powered beyond 3.3 volts. And then what if there's a sudden surge of power powering the circuit? Yeah, if you didn't have a voltage regulator like the zener diode, all your chips would be fried. Yeah, so it acts as a voltage regulator as well. Yeah. So you may be asking, okay, Nikki, but what if like VCC? Yeah, what if VCC, right, is 5 trillion volts? Yeah. What if here, right, the voltage is 5 trillion volts? Yeah. So what then? Then does the zener diode clamp the voltage down still to 3.3 volts? Where does the rest of the voltage go? Yeah, because if let's say let's say the voltage of 90 volts, right? Then if it clamps down to 3.3 volts, like where did the rest of the 86.7 volts go? So it actually gets it gets eaten by the zener diode. It gets dissipated off as heat. Yeah. So the voltage that so it clamps down the voltage, right? Then the rest of VCC, it gets just dissipated off as heat. And this is terrible for the zener diode because you could have like 200 degrees Celsius. Your zener diode could heat up to 200 degrees Celsius, causing it to burn up, maybe start a fire, and that's extremely dangerous. So in a practical setting, or like in a question, you question, you will see the zener diode represented like this. So everything here is the same as this setup here. It's just that there's a resistor. And the point of the resistor is to eat up the heat. Because you know resistors are built for resistance. So, and with resistance there's going to be a lot of heat produced in all that crap. So if you just put a resistor here, the burden is immediately lifted from the zener diode to eat up the rest of that voltage and to like produce that heat and shit, you know, because energy can't be destroyed, so it has to go somewhere. So it has to, it's this place for heat. Yeah. So the resistor is the one that heats up in this case then. So if you are tasked to design a circuit with a zener diode, add the resistor so that your zener diode does not explode in the case where it is. Yep. Okay, and that is zener diodes. So thank you for watching this video. Yeah, and that's zener diodes.